This video is for week 2 of Math 63. So I'm going to go through the assignments here this week. They all have to do with decimals. I think the first one I'm going to do is the handout on ordering decimals. Okay, so let's talk about this one. Problem 2 on that handout, we've got a list of decimals: 0.201, 0.19, 1.2, and 0.21. Okay, so the idea here is that we need to write these in order, let's see, from least to greatest. Okay, so we want the smallest one here, we want the biggest one here. All right, so let me first talk about a good way to solve the problem, and then I'll talk about some other things that go into this, okay? So you don't have to use this method, but this is, I think, a good way to think about what's happening. So let's write these numbers down in a way that lines up the decimal points and the place values, okay? Now, the longest number here has 3 numbers after the decimal place, so let's make them all have 3 numbers after the decimal place by filling in the zeros, okay? Now, if we do that, we can just compare the numbers, okay? So here's the biggest one, here's the smallest one, because it has a 1 there where all the other ones have 2. So 0.19, next. So this is like 200, 201, and 210. Now this one is actually 1.2. I didn't see that 1 there for a minute. So this is going to be the biggest one. So then we're going to have the 201 and the 210 there. So 0.201 and 0.21. And then the 1.2 will come last. Okay. So that's one way to go about doing this. What's really happening here, let's see if I write these down again, another way to go about doing this, right, is to compare the place values. You can see in the ones place, this is going to be the biggest one, right, because it's got a 1 in the ones place where the other 3 numbers have a 0, okay? So now if we look at those other 3 numbers here, here, and here, in the first place value where they're different, the 10th place, this is going to be the smallest one because it has a 1 there where the other ones have a 2. So that's the smallest one. And then which one of these is bigger? Now, I've done this, and a lot of textbooks do this as well, to try to fool people into thinking that this is 21 and this is 201. But that's not the case, okay? Here, this has a 1 in the hundredths place, this has a 0. That means this one's bigger than this one. And when you add those zeros in, then you can say, yeah, 210 is bigger than 201. But if you look at it here, you can't think of this as 21 and this is 201 because of the place values, okay? So I'll talk about that more with some of these other examples, but let's keep working on these. Let's see here. Problem 4. We start out, we've got 0.465, 0.4053, 0.47, and 4.5. Okay, so you can see I've got kind of the same thing here. It looks like maybe this one's bigger than this one, but that's not the case, right? Because this has a 4.0, this has a 4.7. That 7 is going to make it bigger than this one. So let's go ahead and write these down. 0.465, 0.4053, 0.47, and 4.5. Then we'll fill in all the gaps here with zeros, and now we can just compare the numbers. This one's clearly the biggest because it has a 4 in the ones place, so out of these 3, here's the smallest one, 0.4053. And then what? Here's the next biggest, 4650. And you can leave that 0 on the end if you want to. It doesn't make it wrong if you do. 0.47 is next. And then 4.5 is the biggest. And then again, let me rewrite this the way it looked originally. right? So you don't have to add the zeros if you don't want to. You can just look, oh, these all have a 4. So here's the biggest one. So now these three, they all have a 4 in the tenths place. So let's look at the hundredths place. So here's the smallest one, and then the next, and then the next, and then the biggest one. Okay, so that was problem 4. Let's look at a couple more here. Problem 6, we've got 0.51, 0.583, 0.6, and 0.5126. So again, this one might look small because there's only one digit there, but this is in fact the biggest number in this group. And if we write them out with the decimal points lined up, then that will be easier to see. We'll put the zeros in here. Okay, they've all got zeros in the ones place. So let's see here, 5100, there's the smallest one, 0.51. Then 5126, and then the 5830, and then the 0.6 will be the biggest one. Okay. Let's see what else here. Let's do number 8. Yeah, we'll do 8 and 10, and then we'll move on. 0.04, 1.25, 0.156, and 2.3. Okay, so let's line them up along the decimal point. 0.04, 1.25, 156, 2.3. Okay, so here's the biggest one because it's got a 2 in the ones place. Let's see. Now, I'll do this one without adding the zeros, let's say. Okay? So these two are the smallest ones because they've got zeros in the ones place. And now, so let's look at the next place value over. In the tenths place, this has a 1, this has a 0. That's the smallest one then. 0.04. And then this one would be next. 0.156. And then it's pretty clear here. This one's next, and then that one is the biggest. 1.25. 2.3. And there's nothing wrong with adding the zeros. You can do it or not do it, whatever is easiest for you. All right, last one on the handout, problem 10, 0.76, 0.7, 0.076, 0.0710. Okay. Well, let's go ahead and write them down with the decimal point lined up. Okay, and we can put the 0 on the end of that one or not. So they've all got a 0 in the ones place. So let's look at the tenths place. These both have a 0, so these are the two smallest. They match up in the next, so they match up here, match up here, match up here. Here's the first place where they don't match up. This one's smaller, that one's next. So 0.071, 0.076. Next, these two. So you can put a 0 here if that helps you. This is like 70 and this is like 76, 70 hundredths, 76 hundredths. So this one comes next, 0.7, and the 0.76 is the biggest one. Okay, so this is a pretty, I think that this is an interesting topic. I'm pretty interested in the number line myself, and so I think ordering fractions and decimals really helps you to understand what's going on with the number line. All right, now let's go to page 64 in the textbook. So this is all about rounding, okay? So remember, for rounding, 5 through 9 means you go up 1. 0 through 4 means it stays the same. It doesn't go down, okay? I mean, if you want to think that it's getting smaller in one sense, that's fine, but the number in the place you're rounding to won't change. So let's look at problem 32. We've got a decimal here, 3, 0.52612. All right, and we want to round this to the tenths, the hundredths, the thousandths, and the 10,000ths. Okay, so if we round to the tenths place, then we look at the number next to it. This is a 2, so that means it rounds down, so that means that 5 stays the same. That's why I didn't put a down arrow on that. So yes, this number is smaller than this number, that's why we call it rounding down, but that number 5 stays the same. Now, if we're going to round something up, like in the hundredths place, right, look at the digit next to it, it's a 6. That means that 2 has to go up to a 3, 3.53. Okay, next we'll look at the thousandths place. There's a 1 there, so that's going to be 3.526. And rounding to the 10,000ths, there's a 2 after it, so that's going to round down 5261. Okay? All right, we'll do a couple more of these. Let's see here. Let's look at 34. Oh, actually, let me use that same chart that I was using here so I don't have to remake it. So 34 is 36.109. 053, I believe. 109,053. Okay. So the tenths place has a 1, and then next to it is a 0. So this will be 36.1. The hundredths place has a 0, and next to it is a 9, so that's going to round up to 36.11. Hundredths place has a 9, next to it is a 0, so that's going to be 36.109. And then the 10,000ths has a 0 there. The one next to it is a 5, that's going to push it up 1, 36.1091. Okay. All right, let's see here. What else? I'm just going to do one more here. Let's do problem 40. Okay, problem 40.0876543. Okay. 0876543. Okay. So the tenths place has a 0 in it. Next to it is an 8. That's going to push it up to 0.1. The hundredths place has an 8. Next to it is a 7. That's going to push it up to 0.09. Thousandths place has a 7. Next to it is a 6. That's going to push it up to 0.088. And then the 10,000ths place has a 6. There's a 5 next to it. That's going to push that up to 0.0877. Okay. So here's something that happens from time to time. So let's say we've got 07.147. Okay? And let's say we want to round this to the tenths place. What's next to the tenths place is a 4. This rounds to 7.1. Okay? Now, if we rounded it to the hundredths place, next to it is a 7. That makes it 7.15. Now, sometimes people want to round this up to a 5, and then they look at it and they go, oh, well, that's going to make this 7.2, right? Because if I round it up, you can't round from a rounded number, okay? You can only round from the original number, and so you don't want to do this double rounding process where you change this digit and then use that to change the next digit. So please don't fall into that trap. Okay, let's move on here. Now we're going to look at page 69, and this is all about computing with powers of 10. computing with powers of 10 or calculating with powers of 10 moves the decimal point. Okay? So if you were to take like, let's take that 7.147 number, and we were to multiply it by 10, now we can go through the process of this multiplication, but what's going to end up happening is that we're going to have 71.47. That's going to move the decimal point one place to the right. And it's always going to move by the number of zeros that are in what you're multiplying by or dividing. Okay? Now, that's for numbers that are bigger than 1. Now, let's say we take this 7.147 and we want to multiply it by 0.1, which is 1/10. Now, in this case, it's going to move one place to the left and make this 0.7147. Okay? One way you can think about this is 7147 over 1,000 times 1 over 10. And so that's going to give us 7147 over 10,000, which as a decimal looks like that. So that's what's going on with this whole moving of decimals process. Okay? So what gets tricky, notice that if you multiply by a number bigger than 1, your decimal point moves to the right so that your number gets bigger. If you multiply by a number that's smaller than 1, your decimal point goes to the left because your answer gets smaller. Okay? All right, well, let's look at some problems on here. Problem 54. Let's make some room. Problem 54, 60,048 times 0.001 times 0.001, or 1,000th. So that's going to move this decimal point 3 places. All right, 1, 2, 3, that's one way to think about it. So I said a minute ago that if we were to multiply by a number that's bigger than 1, right? Let me pull up an example here off of the assignment. Let's see, do we have one here? Sure, okay, problem 62 says multiply 72.4 times 10,000. Okay? So you can count the number of zeros here. That'll tell you how many places to move the decimal. 1, 2, 3, 4. Okay? Here it's the places. This decimal is going to move 3 places. Okay? So it's not really the same as the number of zeros. It all has to do with which power of 10 are you working with. Okay? So this is 10, 100, 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, 1 over 10 to the first, 1 over 10 to the second, and so forth. Okay? It's all about the power of 10. So this decimal point is going to move 3 places. It's going to get smaller. The number is going to get smaller, so the decimal point is going to go 1, 2, 3 places. This will be 60.048. Now you can use your calculator to do these, but I encourage you to think about them and think about what's happening. Okay? Calculator is useful, but for you to effectively use your calculator, you really have to have some understanding about what it's doing. Okay, this one is going to get bigger by 4 decimal places. 1, 2, 3, 4. So let's go ahead, I'll write it down. 1, 2, 3, 4. There's where the decimal place goes, and these open spots have to get filled in with zeros, and so this should come out to be 724,000. Okay, let's look at the other ones on this page. Okay, 56, 5 divided by 100. Okay, so if you're dividing by a number that's bigger than 1, your answer is going to get smaller. Okay, so this starts out as 5.0. We're going to divide it by 100. That means the decimal point's going to go to the left 2 places, 0.05. Alrighty, let's see here. Problem 58.00425. These are small numbers. 00425. That is going to get divided, or no, multiplied by 0.001. 1,000th. Okay. So we're multiplying by a number that's smaller than 1. This number's got to get smaller. It's probably not very happy about that. It's already pretty small. So that means this decimal point's got to go to the left 3 places. 1, 2, 3. It'll be there. We'll put zeros in those empty spots. And there it is. There's our answer. That's a pretty small number. Towards the end of the term, we'll talk about scientific notation. And so we would write this, let's see, 1, 2, 3, 4, 5, 6. This would be 4.25 times 10 to the negative 6. Don't have to worry about that right now, but that's the scientific notation for writing these really, really small numbers and also really, really large numbers. Okay. I think we've just got one more we haven't looked at here. Problem 60, 92.475. And this is going to get divided by 0.0001. 0001, or 1/10,000. Okay, so remember, if you divide by a number that's bigger than 1, your answer gets smaller, right? 10 divided by 5 equals 2. It got smaller, okay? But if you divide by a number that's smaller than 1, let's say we divide by 1/3, your answer will be bigger than what you started with, okay? So that is why this decimal point is going to move to the right 4 places to the right. 1, 2, 3, 4. Put a 0 in that open space, 924,750. Okay, so there we go. That's multiplying and dividing with the powers of 10. Like I said, you have a calculator. Feel free to use it. But I encourage you to think about what it's doing and to think about how to do it without the calculator and use the calculator to check yourself. Okay. On problems 83 and 84, we've got some questions about unit rates. So this is kind of like what they do in the supermarket. I'll talk about that more in a minute. Let's see. Problem 102. Well, actually, let me talk about the supermarket example. Let's say you can buy 12 ounces for $1.43, or you can buy 16 ounces for $2. Which one's the better deal? Well, here, if you need 16 ounces, well, then you probably should get the 16-ounce package. But if you want to just get the cheapest one, you have to be able to compare these in some way. And so that's unit cost here, is we want to divide the price by the number of ounces, and that'll tell you the cost per ounce. Okay? If you ever hear the word per, that means divided by. Okay? So, cost per ounce means you do the cost divided by the ounces. 1.43 divided by 12, about 12 cents. 12 cents an ounce. Okay, what about this one? Cost divided by ounces. $2 divided by 16 ounces comes out to be 12.5 cents per ounce. So even though you're getting more in this package, you're paying more for it. Okay? So that's what we're going to be doing with these problems. And so wherever you see the word per, that means divided by. So problem 102, 180 calories per 16 ounces. Okay, so we just want to do 180 divided by 16. And that's going to give us 11.25 calories per ounce. And that can help us to compare things. That's the great benefit of finding a unit rate. Let's see here. Well, let's look at problem 104. Something here, we've got 9.5 pounds per 4 square inches. Okay, so that means we just want to do 9.5 divided by 4, and that comes out to be 2.375 pounds per square inch. Okay, let's see here. Problem 10. Oh, well, let's look at 106. 527 miles in 9 hours. 527 miles. Now it says 9. It could say per. Okay, and if you think of this in terms of speed, miles per hour, that means miles divided by hour. So we want to take that 527 and divide it by the 9. So that's going to give us 58.5 repeating miles per hour. If you want to write MTH, that's fine as well. Okay, and then problem 108 is a paycheck problem here. We've got $798 for 40 hours. You could just as well say per there, okay? Because we're going to have to calculate dollars per hour is what we're going to end up calculating here. So we got to do 798 divided by 40, and so that gives us about $20 an hour, $19.95 per hour. Okay, let's see here. What else? Oh, and then on the next page, on page 84, we've got some unit cost problems. Problem 118. Soap, they're selling 4 bars for what? $3.39. And so we want to take that $3.39 and divide it by 4, and that tells you it's going to be about, and that little curly equals to means about, because I'm rounding off to the nearest penny, per bar of soap, for 1 bar of soap. Okay, let's see here. What else do we want to look at? Now let's look at problem 126. Here we've got cans of cat food, $4.32 for 12 cans. So that means we got to do that 432 divided by 12. And that'll tell you that it's going to be 36 cents per can. Okay, and then we end with these better buy questions. So that's what I was talking about at the beginning here. So let's look at problem, 128. We've got 6 ounce for $3.19, or 7.8 ounces for $5. And is that also 19 cents? There we go. Okay. So, in unit cost, typically, we're going to divide the cost by whatever the size is, okay? So, in this one, we have to do $3.19 divided by 6. So that's about 53 cents per ounce. And then 519 divided by 7.8, that's about 67 cents per ounce. So this one is the better buy. It's cheaper. I mean, I suppose there may be other factors that go into which is the better buy, but here what we're asking for really is just which one is less expensive. All right, let's see here. Problem 130. We've got breakfast cereal, 10.7 ounces for $2.69, or 14.8 ounces for $3.69. Okay, so let's go ahead and divide 269 divided by 10.7, about 25 cents per ounce. And then this one, 369 divided by 14.8, also about 25 cents per ounce. Okay, so in this case, rounding to the nearest penny is not really all that helpful. So this one is 25.14, and then this one is 24.93. So this one is the better buy, but not by a whole lot. Okay, you're gonna save a little bit of money on that on this one, but it's really not that big a difference. Okay, let's see here. All right. All right, let's look at page 94. So this one is the order of operations. Okay, so let's talk a little bit about the order of operations. If you've had this previously, you may be familiar with the mnemonic device PEMDAS, which can help you to remember parentheses, exponents, multiplication, division, addition, and subtraction. That's helpful. So let me talk about where this PEMDAS idea comes from. So the simplest operations in arithmetic are adding and subtracting. Okay? So those are the simplest operations. Now if you do repeated addition, like say you do 2 plus 2 plus 2, that's 3 times 2. So that gives us multiplication, and then the opposite of multiplication, which is division. And you can also use the fraction bar for division. Okay? And then if you do repeated multiplication, let's say you do 5 times 5 times 5, that's 5 to the 3rd power, okay? So the repeated multiplication gives you exponents, and the opposite of exponents are roots, okay? Now, if I put parentheses at the top of this, this is the order of operations. Okay? It says start inside the parentheses, simplify inside the parentheses first, and in terms of what order to go in, do the most complex calculations, exponents and roots first, then multiplication and division, and then save all the adding and subtracting for last. Okay? So, there's 2 different ways to think about the order of operations. The PEMDAS can be helpful to you. Also, this sort of governs that order of operations. So let's look at some examples. Let's see here. Problem 2. Oh, this is a good example, I think. Problem 2 says 37 minus 1 times 6 squared. Well, I would change that to make it a little bit better example, but it's fine as is. Okay? So there's no parentheses. So immediately we want to look for exponents and roots. Here's an exponent right here. 6 squared is 36. Now, no more exponents or roots. Good. We can do multiplication or division. Here's some multiplication. 1 times 36 is 36. Very last thing we do, subtraction equals 1. All right, let's look at problem 4. What do we have here? 4 squared minus 2 times 4 minus 2 to the 3rd power. Okay, well here we do have a set of parentheses, so let's work inside the parentheses first. Inside the parentheses, we follow this order of operations. So we want to do the exponent first. 16. You can do this exponent at the same time if you want to. It doesn't make any difference. I'll save it until we get rid of the parentheses. Let's see here. Now, inside the parentheses, we're going to do that multiplication. 16 minus 8. So now, we'll get rid of the parentheses. Do the other calculation. Save that subtraction for last. Comes out to 0. Okay. Problem 6. 121 minus 4 times 5 minus 12 plus 16 over 2. Okay, so those brackets are the same as parentheses. They're just a different shape, but they do exactly the same thing. I left out the dot that was here in the textbook. I'm not in the habit of putting a dot there. You can use it or not use it. Whether it's there or not, this indicates multiplication. Okay? All right. So let's work inside the parentheses first. So that'll be 20 minus 12. And now let's go ahead and simplify that. That'll be 8. So here's some multiplication. Here's some division. We'll take care of those next. And now notice we're down to just the adding and subtracting. So let's see here. So the sign for a number is always in front of it. This is a positive 8. This is a negative 32. Okay? So you can go in any order you want, but you can't go like 121 minus 8. Okay? That minus is attached to the 32. That plus is attached to the 8. And if there's nothing in front of a number, that means plus. All right, let's see here. So 121 minus 32, what is that going to be? 89 plus 8 should be 97. Okay. Well, let's keep going with these. All right, problem 8. What do we have here? 8 times 6 plus 20 over 4 plus 3 times 6 plus, what is that, 16 over 11. Okay, so let's work in the parentheses first. So this will be 8 times 26 over 4, 3 times 22 over 11. Let's see here. So I'll go ahead and multiply. If you want to cancel these here and here, that works as well. But let's go ahead and just do 8 times 26. Is that going to be 208, I believe? Yeah, there we go. 208 over 4 plus 66 over 11. So this will be 52 plus 6 makes 58. All right. Well, we'll look at a couple more here. Let's see. What do we have? Okay. Well, let's just do one more here. Problem 12. This one's nice and complicated. 6 times 2 times 8 plus 3 minus 5 times 2 plus So one thing that's helpful in doing problems like this, if you ever see something this complicated, and this is true, you know, throughout mathematics, into like the college algebra classes I teach, and Math 70 and Math 95 and all of that. So if you can look at this as grouped and separated by the addition and subtractions, right? So here's a piece, here's a piece, here's a piece, and here's a piece. So there's like 4 separate pieces in there, okay? And that can help you to break it down and think about what to do when, okay? So first off, we want to get these parentheses taken care of. Let's do these ones first over here. 1 plus 8 is 9, 1 plus 11 is 12. All right, now let's work over here. This will be 16 plus 3. Okay, so now let's finish off this parentheses here. That'll be 19. 5 times 2, 8 over 4. And I'll leave the 9 times 12 here. And then we'll do all of our multiplications and the division too at the same time. Okay, so let's see. That's going to be 114. All right, yeah, 114 minus 10 plus 2, and then this I think is 108. 90 and 18, yeah. Okay, great. So now, let's see. So this will be 104 plus 2 is 106 plus 108, 214. Okay, so that's it for this week's assignments. Let's see here. Yeah, so we'll have a Zoom conference on Friday. Hopefully you'll have had a chance to look at the assignment, and any questions that you have, you know, you can ask then. It'll be during the time the class was originally scheduled, 12:30 on Friday. If you're doing fine with the problems and don't have any questions, then you don't necessarily need to log into the Zoom conference. But if you want to make use of it, we'll be doing that every week. As always, if you have any questions, please let me know. Thank you.